All right, here we go. I asked you to do 3 through 6. We did number 5 in class. And so I think 3 is really straightforward. And 6, the only issues you're going to have with that is when you take derivatives of this, you're going to get negative exponents. So you're going to get x's in the denominators. So you will get, you have to consider where is f prime of x where it doesn't exist. Okay, I'd like to do number 4 because it's got trig functions in it. So we don't have to do these all in this same order. We're just going to cover them all because we want to find critical points, max and mins, concavity, and all of those sorts of things. So start with the derivative is 1 plus the cosine of x and set that equal to 0. Nowhere is this undefined, so I don't have to worry about that. So cosine of x is negative 1. And think on the unit circle, where is the cosine of x equal to negative 1? Because my domain is from 0 to 2 pi. So I only have to worry about those values. So x is pi. So if I want to see if that's a max or min, I look at the derivative and see if it changes sign there. So at pi, or numbers less than pi, like pi over 2, 1 plus the cosine of pi over 2 is 1 plus 0 is 1, which is greater than 0. And here, say 3 pi over 2, cosine is 0. F prime is 1 plus 0. So it's going to be greater than 0. The other way to think of it is the cosine always goes from between 1 and negative 1, right? So if I add 1 to this, I'm going to get 0 less than or equal to 1 plus cosine of x less than or equal to 2. So this is always going to be positive or 0, which it is right there. So that means x equals pi is either a min or a max. And I know the y coordinate at pi is going to be pi plus sine of pi. Sine of pi is 0, so it'll be pi. So this point right here, pi, is neither a min or max, but I know it's flat right there at that point. So let's check the endpoints. When x is 0, y is 0 plus the sine of 0. Sine of 0 is 0. When x is 2 pi, y is 2 pi plus 0. Okay. So we're at a point now where we can kind of do a little bit of a sketch. Okay, that's what we got. I know it, well here, let me draw it differently. I know it goes through the point 0, 0, pi, and then out here if we call that 2 pi, and then up here would be 2 pi. It'd be like this. So it increases to this point, but I know at that point it's got a flat spot because the derivative is 0. So it's got to come up, flatten off there, and then curve back up. Okay. All right. So that's the sketch of it. Now we want to look at concavity and inflection points. Inflection points are where it changes from concave up to concave down. So it looks like here might be concave down. I don't know if it's a straight line or not there. We're going to find that out. It looks like it's concave up there. So let's check out concavity. Let's look at the second derivative of x is the derivative cosine is negative sine of x. And we want to find out where does it change from positive to negative and negative to positive. Well, that's when it's this is equal to 0, when the second derivative is 0. So the sine of x, that means the sine of x is 0. So where is the sine 0? Again, on that interval right there. That'd be pi over, thinking cosine. The sine is the y value on my unit circle, so x would be 0, pi, and 2 pi. That's where the sine is 0. So let's check concavity on these intervals. So from 0, pi, 2 pi. Remember, I only care about what's in between 0 and 2 pi. So I know the second derivative. From 0 to pi, the sine of x is my y coordinate, so it's going to be positive. And from pi to 2 pi, it's going to be negative. Again, I'm thinking unit circle, right? The sine are my y values. Okay, so it goes from, let's see, second derivative is positive, it's concave up, negative concave down, so that makes x equals pi, y equals pi, and oops, inflection point. Okay, does that make sense? Now, I know now I'm going to say some things. I'm going to summarize some of the things that they asked. Okay, so we got a global minimum at x equals 0. We got a global max, oops, at x equals 2 pi. The minimum value is 0. The max value is 2 pi. It never hurts to add those things in there. Okay, it's increasing. When the first derivative is positive, right? Here and here. So it's but not at pi. It's not increasing at that instant. So it's increasing on the interval. Now, the question is it increasing at that point? Oops. Well, it's not flat there, so we're going to go with 0 to pi. Or it's also, well, and it's also increasing over here on the interval pi to 2 pi. All right. Where is it? Concave up. That's this interval here. From 0 to pi, but don't include pi. And it's concave down on the interval pi to 2 pi. Okay. I think we covered everything on there. Yep, sure did. Okay, so there's the whole problem right there. And hopefully that gets you set up for all of the mins and maxes and concavity and things like that. All right, we'll leave that one on its own.